So let's begin. I think I have explained a bit last Thursday on this part. So in centroid, we talk about centroid and center of gravity. In chapter 5, we talk about centroid most of the time. It is based on geometry. So centroid is based on the center of area. So and center of gravity is based on the center of the downward force. For example, that we have a, let's say we have a piece of material. It looks like this. With half of it as steel and half of it as plastic. And so when we talk about centroid, it is about the center of area. So the centroid of the area is here, right? Because it is based on the center of area. It is a square. This is a square with side length A. So in English, we will say this is a square with side length A. So the centroid is located in the middle. Located at the center, sorry. Located at 位于哈 So we look at a square with side length A here, and the centroid of the square is located at the center. Even if the left-hand side, the left half is made of steel, and the right part is of plastic. But as you know that the center of gravity, which is the average of the downward force, is centered here because this is heavy and this is not heavy. This is and this is light, right? So the center of gravity is somewhere on the left. So this is the difference between centroid and the center of gravity. So this is the difference between centroid and the center of gravity. If the area is made up of different materials. Now, if the member, you take a time to write it down. So if the member is made up of a single material, which is homogeneous, that the center of a member coincides with the center of gravity, that they are on the same, they are on the same point. They are at the same point. Huh? Now, of course, I have named one counter example last Thursday. Counter example is 反例. Counter example is 反例. And of course, the double-decker bus is one counter example, and another counter example is the shape here. So there are some new words for you to learn, and so counter example, and remember located is at, and when we say square with side length a, that it is it means one side is a and another side is also a. It's okay. That if you are finished copying these, then you can go to the next page. If you are finished writing these, then you can go to the next page. Now we have something called symmetry. Symmetry. Symmetry 对称. So in this is the noun, and this is the adjective. 名词跟形容词有学过吗？ Good. And symmetry is the problem is in English that the noun is called symmetry. The accent is here, and for adjective it is called symmetric. Okay. The accent is at the M here, and for noun that the accent is here, symmetry. And for adjective it is symmetric. Now, and here after that, there are some words that you can learn that with respect to means 相对于. And usually I will write WRT, and it means with respect to. And there exists an area. Exist means 存在. And bisect is 对切, 对半切. So just write down the words, and so of course you know something is symmetry and something is not. Something is symmetric and some other members are not symmetric. But here gives a form. Here gives a definition. 定义啊，这 here gives a definition of symmetry. This is the definition of symmetry. So, and so we say the area is said to be symmetric with respect to B and B prime, and this is the line of symmetry. Let me write use red pen here. This is the line of symmetry. So we say the area is symmetric with respect to B and B prime. And if for every area dA on the right, and there is a area on dA prime on the left. So for every area dA on the right, and there is a area dA prime on the left, and these two lines are the line connecting the two areas. This is a line is perpendicular to B and B prime, and this line B and B prime bisects dA and dA prime. So Of course, that on the right we have a dA here, and on the left we have a dA prime here. And here we have we say if we join two lines, if we join two areas together, so this dA prime means a line joining the two areas. So it goes through B and B prime, and this B and B prime bisects dA and dA prime. So this is a definition. So of course, in daily life, and of course, you know something is symmetric and some other areas are not. But here is a definition. And on another type of symmetry, like the S shape, like this shape, and it is not symmetric according to the definition here, but you know it is a regular shape that it has some form of regularity. So this time we call rotational symmetry. 旋转对称。So an area is said to be symmetric with respect to O if for any area dA at xy there exists an area with coordinates negative x, negative y. So we have two types of symmetry. I will give you another example of symmetry in a minute. After these definitions, so take your time to write this down, and after that we will go to something you need to memorize in the examination. Now we go to the next part. That's the center of gravity or centroids of common shapes and lines. So requirements in examination, that it means you need to memorize those. You need to memorize those, and for 2D shapes, it includes a triangle, and quarter circle, and arc circle. These are on pages 239 and 240. So for a triangle, with height h, the centroid is located at 1/3 of its height. For example, that you need to memorize. This. And for circle, with radius r, the height here is 4r/3 pi. This is an area. Okay, I will explain why I would like to write this. It's an area. And the last type is arc circle, which is a line. Let me use a very thick line here. And we have the radius r, and we have angle alpha and alpha here. And so this is x. So x bar is equal to. I'm sorry, that's I made a mistake here. Please correct this. Here is this. Please correct this for me. And x bar is equal to x bar is equal to r sine alpha over alpha. So you need to memorize these three in the examination, and I will not give you equations in examination in 3 weeks' time. So take your time to draw them. And for take your time to draw this. Very good. That this x bar is the distance between center and okay, from the center C to the centroid here. Now, 动五是 over， 动的 this is over。我们应该140加2。So and your friend has asked whether this is our alpha. This is alpha, and I will show on Thursday or next Tuesday why it is alpha. And this is the x bar is the centroid of this line. Suppose we have and I will explain in a minute. Now for using these equations, remember 2 points. The first point is alpha is in radian. Radian 弧度。Not degree. And the second thing, the length of the arc is 2 alpha r, and so it means the angle goes from minus alpha to plus alpha.